Hi guys, these are our notes for solving log and exponential equations. This is going to go in our slides presentation on slide 15 and 16 when we're done. So at the top of your paper, you can go ahead and put your title, Notes Solving Exponential and Log Equations. We're going to go ahead and start with solving exponential equations. I'll give you guys just a couple of little steps to follow. So the first thing you want to do is go ahead and isolate your exponential piece on the left side. We won't be able to use it solving exponentials because your x is going to be in the exponent. So what you're going to have to do is change to log form using the loop trick. Then you're going to go ahead and evaluate the log piece. And finally, solve for x. Here's our first example. It's an example, it says 3 to the power of x plus 2 equals 5. So we don't know 3 to what power is 5. We don't know 3 to what power is 5. So what we're going to have to do is isolate our exponential piece on the left. This is our exponential piece. It's on the left. It's already by itself. So we can go ahead and change forms using the loop trick. So if this is exponential, I'm going to change it to log form. So it'll be log base 3 of 5 equals x plus 2. All right, well, I try to see if I can evaluate this log piece using mental math, but I don't know 3 to what power is 5. That's the question you ask yourself, 3 to what power is 5. We don't know that one, so we're gonna have to go ahead and use our calculator. So there's no log base 3 button on a normal calculator, so we do the change of base formula. It'd be log over log. The base goes in the bottom, that's 3. It's now a normal size, and the 5 goes on top. So equals x plus 2. I'm going to go ahead and solve that. Log 5 divided by log 3 using Desmos. So I do my functions. I do log 5 divided by log 3, and I get 1.46497. I didn't say where to round, so we'll just do 3 decimal places. So it's 1.465 because the 4 rounds up. 1.465. Equals x plus 2. So it's the evaluate log piece. Now we're going to go ahead and solve for x. So to get x by itself, we're just going to subtract 2 on both sides. So I get x equals, I'm just going to go up here. I'm going to go after and just write minus 2, and it'll give me my answer. Negative 0.535. Negative 0.535. Remember, it's a approximation because we had to round our decimal. But if I raise 3 to the power of negative 0.535 plus 2, it should equal 5. All right, we have 2 more of these exponential examples. So our next one says e to the power of x minus 3 equals 5. So again, we isolate our exponential piece. It's already isolated on the left side. There's nothing attached to it. So we go ahead and do the loop trick to change forms. So we're changing it to log form. So it becomes log base e. But we don't write log base e, we write natural log, so it's ln. It's not 1n or in, that's ln. So natural log of 5 equals x minus 3. Well, natural log of 5, there is a natural log button on our calculator, so we don't have to do like a loop trick or a change of base or anything. We can just go natural log 5 in our calculator. We get 1.609. Equals x minus 3, and then we just have to go ahead and add 3 to both sides. So we get 4.609. That's what x is equal to. And we're done. All right, one more exponential problem. So it says 10 to the power of 2x plus 5 plus 2 equals 5. All right, so step 1, we need to go ahead and isolate our exponential piece on the left-hand side. This step isn't done yet because this is my exponential piece, and there's something else on the left-hand side of the equal sign. So first I'm going to start by subtracting 2 on both sides. I get 10 to the power of 2x plus 5 equals 3. Then I'm going to go ahead and do my loop trick to change form. So I change it to log form, so it's going to be log base 10, but we don't have to write the 10 because that's common log. So it's log 3 equals 2x plus 5. One thing you could do so you have to do less work in your calculator later is you could go ahead and just kind of like solve with the log piece and then do the calculator all at the same time. Like I'm going to subtract 5 on both sides. So I have log 3 minus 5 equals 2x. And then if I divide both sides by 2, I can go ahead and type this whole thing into my calculator and get x. So I don't have to like use my calculator more than one time. I can just type this whole thing in right here. So log 3 minus 5 all over 2. So log 3 minus 5. And then I'm going to put parentheses around it so I can do all over 2. So that's negative 2.261. Negative 2.261. Is that what it was? Negative 2.261. Negative 2.261. All right, good. And that's just our answer. Okay, so this is going to go on our first slide for our notes. So these are solving exponential equations. You just get your exponential piece on the left side, do the loop trick to change it to log form. You evaluate your log piece. You usually have to just use your calculator, and then you solve for x. Let's talk about solving log equations now. So solving log equations, we'll have some steps. So the first thing, it's going to be really similar to what we did for those last ones. The first thing, you just isolate log on the left side. We won't be able to solve it using logs because there's going to be an x, so we can't use our calculator. So you're going to change to exponential form with the loop trick. You'll go ahead and evaluate the exponent. And solve for x. There is one special little property that I should have left a little bit more room to write down, but we have a little property that we're going to use for 2 of our examples, and that property is that if log base b of x equals log base b of y, if these two log bases are the same right here, log base b, if those two are the same, that means that these two things also have to be the same. So that just means that x then equals y. So we'll do an example, 2 examples of kind of like solving like that. All right, so let's go to examples. So our first example, we're going to use this little property we just wrote down. So examples, and then write down log base 2 of 3x plus 7 equals log base 2 of 4x plus 2. All right, so you first check to see if your log bases are the same. So log base 2, log base 2. It's just one log base 2 equals another log base 2. Basically, you just cross off your logs and you're going to solve the equation 3x plus 7 equals 4x plus 2, because if the two log bases are the same, then the two x and y piece have to be the same. And then I'm just going to solve for x here. So I get my x's on the same side. I don't see any exponents or anything. So I'm going to subtract 3x. I get 7 equals x plus 2. Subtract 2 on both sides, and we just get x is equal to 5. I switched sides, but it would have said 5 equals x, but just x equals 5. We'll try it one more time. So using this log property, it's just if the two log bases are the same, then x equals y. So our next example, number 2, says log base 3 of x plus 2 plus log base 3 of 2 equals log base 3 of 5x plus 10. So in order to use this property, you have to have one log base equals another log base. You can only have 2 logs. Well, here I see 3 logs. But on the left-hand side, I see log base 3 of x plus 2, and then I changed this one, but log base 3 of 2. So when you have a plus sign in between 2 log bases that are the same, you can actually condense them. We did that last week. So when you condense them, if there's a plus sign in between, that means you multiply these 2 pieces. So x plus 2 times 2, you distribute. X times 2 is 2x. 2 times 2 is 4. And then the other side, there was nothing to condense or anything, so I'm just going to leave it how it is. But on the left-hand side, I was able to condense it because they both had the same log base. This was log base 3, and if there's a plus sign in between, that means you multiplied these two pieces. Now I have log base 3 equals log base 3, so we can just cancel those out, and then we just solve our new equation. 2x plus 4 equals 5x plus 10. And then we just go ahead and solve for x. So I'm going to get my x's on the same side. I get 4 equals 3x plus 10. Subtract 10 on both sides. I get negative 6 equals 3x. So I get, what, x equals negative 2. Before I can say that this is my answer, though, I do have one little problem I have to double check. So something that we need to like put a little starred piece of kind of information about is that if you have log base b of a, both b and a have to be greater than 0. So your base has to be a positive number and your a has to be a positive number. It has to be greater than 0. So if I plug in the number negative 2 for my answer right here, 5x plus 10, if I plug in negative 2 there, and I get, let's see, what do you get when you plug in negative 2? 5 times negative 2 is negative 10 plus 10. If you try to do log base 3 of 0, there is a log base, you can change the base. So here's log base 3 of 0. You're going to get undefined. You're not allowed to have 0. You can't have a log base that's negative either. You can't do like negative 2 and then 4 here. It's undefined. So your log base has to be greater than 0 and your a has to be greater than 0. So this number negative 2 actually doesn't work. We actually have no solution. I didn't go through and check it for this one, but if you plug in 5 here for either of these, you get a positive number. 5 times 4 is 20, plus 2 is 22, 3 times 5 is 15, plus 7 is 22, so it's okay. But you do want to kind of double check your answers and make sure that they're valid. All right, we have 2 more. We're going to use not the property, we're going to use those 4 steps of isolating. So the next example says log base 3 of 4x minus 1 equals 5. So we can't just plug this into the calculator because we don't know what x is. That's what we're trying to find. So what we need to do is we need to go ahead and isolate our log piece on the left. This is our log piece. There's nothing outside of the log, so we're good. Then you're going to go ahead and switch forms. You're going to go to exponential form. So 3 to the power of 5 equals 4x minus 1. 3 to the power of 5 equals 4x minus 1. Well, here we can evaluate this. Just 3 to the power of 5 means 3 times, oops, my highlighter. That just means 3 times 3 times 3 times 3 times 3. Right? If you need a calculator, you can use it, but it's 243. So 243 equals 4x minus 1. And then we can go ahead and just solve for x. So I'm going to add 1 to both sides. I get 244 equals 4. And then 4x. And then I'm just going to divide both sides by 4. I get x equals, well, 4 goes into 24 6 times, and then 4 goes into 4 once, so it's 61. We do double check just to make sure, but 4 times 61 minus 1 is going to be a positive number. That won't be negative. So just make sure it's not negative and it's not 0. All right, then we have 3 log base 2 of 5x plus 6 equals 15. So the first thing we need to do is go ahead and isolate our log piece. So this is my log piece. So it might be kind of hard to see, but there's actually this 3 out there in the front. So we need to get rid of that before we can start. So I'm going to go ahead and divide both sides by 3 to begin. I get log base 2 of 5x plus 6 equals 5. 15 divided by 3 is 5. Then once my log piece is isolated, I'm just going to go ahead and do the loop trick to change forms. So 2 to the power of 5 equals 5x plus 6. 2 to the power of 5 equals 5x plus 6. Well, 2 to the power of 5 means 2 times 2 times 2 times 2 times 2, which is 32 equals 5x plus 6. In order to solve for x, I'm just going to subtract 6 on both sides, so it cancels. 32 minus 6 is what, 26? Equals 5x. and then just divide both sides by 5. And I get x equals 26 over 5. Can't divide in evenly. That fraction can't be simplified. I'm just going to leave my answer like so. I do double check just to make sure that when I plug it in, I'm going to get a positive number. And that's it for our examples. You guys are going to try a couple for your classwork, and you'll have a quizzes, little classwork too, so you get a lot of practice in. So the first one goes on slide, I think it was 15, and then slide 16 for the other notes. And that's it.